Alright, welcome to another AQA A-level chemistry video. Today I'm going to be doing a video on gas chromatography. Like the previous videos, this is going to be quite a straightforward video. You just basically have to understand. I mean, as I said before in the previous two videos, have a good understanding of what the stationary phase is, and the mobile phase and the affinity. Today, the affinity isn't really based off of polarity, but most to do with volatility. But yeah, I mean, as long as you have a good grounding of that, this will be quite straightforward video for you. And also good understanding that gas chromatography is, as it says in the title, is good at separating out gases really from a compound. We vaporize a liquid of some sort or solid, and we can separate the gases and use the retention time of when they were separated to determine the compound. But if that's not, sometimes that's not the best way of being able to identify a compound by retention time of these gases, because it can be quite short and narrow. One of the better ways of doing it is that realizing that gas chromatography is separating out those solids. So we're separating out those pure gases. If we're separating out pure gases, then we can just attach a mass spectrometer, which is really good at identifying it's very bad at separating out, but it's very good at identifying pure solids, or so pure gases or pure substances, essentially. But I mean, it's very good at. I mean, you have to vaporize a compound in mass spectrometry anyway. So and gas chromatography already does that for you. So you can just attach a gas chromatograph gas. Sorry, you can just attach a gas chromatogram or gas chromatography mechanism really. I shouldn't say chromatogram. Chromatogram is after chromatography. You can attach a gas chromatographer to a mass spectrometer, and then using both of those together, you can then be able to split and identify specific compounds from a mixture. Now, enough of that from the introduction. I'm just going to get straight into the video. So, gas chromatography, or GCs, is I'm going to shorten it down, is another type of chromatography. The experimental setup is that you have a column is packed with a solid. A mixture of the vaporized sample is then passed through a column in an inert carrier gas under pressure at high temperature. The sample needs to be a gas, liquid, or volatile solid to be carried through the column. The high pressure causes the sample to vaporize. So in mobile and stationary phases, right? So mobile phase is the inert carrier gas, which is going to be in here. This flow control just allows us to basically act as a controller. Sample gets injected here. So the sample injector is here. So this helps us to inject the substance into the column. So we have our carrier gas here of us, which should be some sort of inert gas, which helps to allow us to so it helps allow the sample, once it's being injected, to actually pass and move through the column. So carrier gas here acts as the mobile phase, which is the inert carrier gas. The stationary phase would be the solid in the column. So this solid in the column, that would be the stationary phase. The carrier gas, so here as I said before, I'll choose a different color now. Oh. Here, as I said before, is where we would inject our sample. So we allow this flow controller here is really just to make sure that we're maintaining good pressure, because we want to make sure that we control that. It's very important. The carrier gas here is acting as the mobile phase, and once that we allow that to pass, we can then inject our sample through the sample injector, and that allows the sample to move across the stationary phase with the mobile phase. And then we have our little detector here, and then that'll tell us how long it took from the moment that the sample was injected to the point that it reaches the detector, and we can use that really as our retention time. Now, the most volatile substances would elute from the column first, as they will spend more time in the mobile phase. So the more volatile it is, remember volatility is how easy a substance turns into gas. So the more volatile it is, the more quickly it will elute from the column, because it has a higher affinity to the mobile phase, and the mobile phase here is the carrier gas. So the more easy it is it turns into gas, the more easy it is for the carrier gas to move and carry that sample, obviously the gas sample, towards the detector, or across the stationary phase, and to reach the detector. Hopefully that made sense. So hopefully this whole process made sense to you. Hopefully there wasn't any confusion. And yeah, I'm gonna go through that. Remember our sample is vaporized. This is a vaporized sample that we're injecting. Alright, so gas chromatography, and it was GCMS. So GCMS is gas chromatography coupled with a mass spectrometer. So like I said in the introduction, we've now separated out our. If we've done this process and we got up to here, we've now identified. You can identify compounds by just doing gas chromatography, but sometimes it can be a bit difficult because the gas chromatography, there's not a huge difference in the retention times. Sometimes there are, but it can be a bit difficult to decipher, and it may not be that. It may just be that you have different retention times, but it's not really clear what compound is what really. So one thing we do know is that, okay, we've done that now. We have done that, but what we have realized now is that since we've separated out our compounds into separate pure, if you've separated out your gas, sorry, I'll start again because I really don't want to confuse people here. So we've now vaporized our gas mixture, right? And we now separated our gas mixture using column chromatography. Sorry, using gas chromatography in the column. I really want to start again because I really don't want to confuse people. I'll start one last time, so hopefully people kind of get what I'm trying to say here. What we've done here is that we've vaporized our sample, we've injected our sample, and that's a gas sample. We vaporized our sample, it's a gas sample. That's a mixture now. And now we've separated the different compounds in that mixture of gases using gas chromatography, but in the stationary phase here of this column here. That's the hopefully you're following up to what I've got to now. So now once we've done that, once it's passed through the column, you can see these little parts here, right? It then different gases will reach the detector at different. So the detector's here. I don't know why I did the detector here for some reason. This is the detector. So the detector will be here, or you could use. So you can either use the detector that I've had here, it could be a computer, or you could use a different type of detector. Now, the different type of detector that they could use is also a mass spectrometer detector. I say this because we've now separated out our gases, and we have separate pure gases. Now, a mass spectrometer is really good at identifying pure gases by using their mass to charge values, and that's why using a mass spectrometer detector is one of the best detectors that we could use to identify, to couple up to a gas chromatography mechanism, because we know that gas chromatography is not as good at identifying, but it's really good at separating out gases from a gas mixture, because as I said before, it's separating out by the different volatilities, and they'll reach this point here at different times, obviously, because they'll have different retention times, and then once they've reached here, they'll go straight to the mass spectrometer, and you should know what mass spectrometry is from year 1 physical. Will I leave the link in the description to that if I remember to? If I don't, remind me. And then once that, then you get a different specific mass to charge ratio value that will represent will help you get an understanding of what type of compound that you have. And you don't have to do vaporization or electrospray ionization. I mean, you have to probably do electrospray ionization. Yeah, that. But at least your compound is already a gas, which is useful. So use of a mass spectrometer. So as I said before, so mass spectrometry identifies the components of a mixture from the mass to charge values, and it can analyze the substances in a mixture, but they must be separated first. So the gas chromatographer, so the gas chromatography can separate the substances in the mixture, and a mass spectrometry can identify each substance eluted. And I suppose that's the word I was looking for here. Oh, the key word here is eluted. So once we've got our sample here, which is the sample is obviously a mixture of different gases. Once the gases have then passed through, have injected into the column, and now are undergoing column chromatography. So I keep saying column chromatography. And now undergoing gas chromatography as they pass through the solid stationary phase, which is in the column, and getting separated out by their volatility. So, as I said before, the higher the volatility, the strongest affinity to the mobile phase, and the more quickly they'll elute, and obviously vice versa. If it's not a very volatile compound, it'll have a high affinity to the stationary phase and a low affinity for the mobile phase, and it will elute slower, and it will reach the detector much more slowly. But even if it, but as I'm saying here, if that isn't as clear, if the retention time isn't as clear, that's fine, because the detector that we're using is a mass spectrometer detector. So therefore, we can just identify what the compound is, because if it's a higher mass charge, usually more heavier compounds are less volatile compared to lighter compounds. So if we have a compound that has a very high retention time, which means that it's eluted very slowly, because it usually means it's very unvolatile. And then once it reaches the detector here, the end of the detector, if you know about mass spectrometry, I'll try to remember to leave a link in the description to that video. It will usually have a very high mass to charge ratio, and that you'll be able to detect that here if it isn't already obvious by the elution time. So where was I? So mass spectrometry can be used alongside gas chromatography to increase the analysis of a substance. It's simply done by attaching a mass spectrometer to a gas chromatography apparatus. Now the two work well together because the gas chromatography is good at separating out substances in a mixture, but they're bad at identification. But mass spectrometry can't separate substances very well, but it's very good at identifying them. Now, the two can be used together to play to both of their strengths. In biology, we would call this a mutualistic or symbiotic kind of relationship. But obviously, we're not talking about organisms here. We're talking about chemistry. But you can see what I mean here is that they work together very well. One is very good at one thing and bad at the other. But one is very good at that thing that's bad at the other thing, but very good, but very bad at what the other thing is. In other words, a gas chromatographer is very, very good at separating out a substance, where a mass spectrometer is very poor at doing that. But a mass spectrometer is very good at identifying a substance, where a gas chromatographer is very poor at doing that. You see, what one thing is bad at, the other one is good at. So they play hand in hand. Gas chromatography, very good at separating substances, but very bad or not as good at identifying them. Mass spectrometry, not very good at separating substances, but very good at identifying them. Now, the processing gas chromatography, mass spectrometry, GCMS, a mixture is added to the gas chromatographer as usual, and each substance eluted from the gas chromatographer is then directly analyzed by mass spectrometer using their mass to charge values. That's it. Hopefully this video was helpful, and that's what I've got